already, so who am I? HPC troublemaker. Yeah, that's me. Wow, gee, okay. I don't need my phone anymore. So the reason why I'm a troublemaker is like, if I deep down I really want to change the world, but I have to be a troublemaker first before I can do that. So that's why. So let's dive into the content. So what I'm going to talk about today is Industrial HPC. Why Industrial HPC? Why we care? Because it's an ATM machine. It generates cash. In particular, in industry, have a very high ROI. Average is like every dollar you spend in it, you probably get $500 back within 2 years. Well, that's from the IDC report. That's why it gets tractions. You can see it in these few years. A lot of companies, enterprise, industrial partners, they get involved into HPC for their simulations, for lots of work. And for the national institutes, they have like industrial partners to do HPC works on their big clusters. That's why we want to raise the awareness of people, tell people what we do internally and how we can collaborate together. So what is Industrial HPC and what's the difference between research and industrial? We are also all commodity hardware. We can qualify to go into the top 500 list, although you don't see us all the time on the list because our capability, capacity is kind of like secret, so we need to hide them. So you don't see us on the list like a lot. We have our systems, not necessarily GE, but like I talk to a lot of like industrial partners, like people range from a couple hundred cores all the way to a couple 100,000 cores. So the range is a long range there. So usually we do not live inside a specific HPC purpose-built data center. We don't. Like usually we live with our enterprise IT. We live with other co-locate customers in the same location. And when you do, I don't know how many of you like deploy HPC system before. I know majority of you did it, but it adds a big layer of like complexity there. It's another challenge. Resources manager. Yesterday we talked about fair shares a lot in a couple of the presentations. It's a fun thing. But fair to who? By what? In research lab, people try to be fair to every single research. All science is important to the humans, right? So, but for us, business project deliverables are the king. I don't care how important you are. If I got a business case, I got the business leader come down to tell us, this is the #1 project, it needs to be finished. Then they will be the top of the queue immediately. So the fair share mechanisms, like the way we operate is very different. We cannot just say fine tune our fair share queue and call for the day, leave it alone, don't touch it. We cannot do that. Computational process is part of the design workflow. It is. Usually people come to HPC environments, they have a project, they have the specific simulations they want to run. They ran a lot of it, and then at the end they leave the system. Okay, I'm done. You can even close my account. I don't care. But in business, no, it's not. So we collect a lot of information from the beginning of the project all the way to the part, start the simulation, pre-processing, computation, and then go to post-processing. Then what? Then it goes back to the business cycle, go back to validate the result, see that the project is good or not, customer likes it or not. If not, then it go back to the beginning of the circle. So our customers come back and forth. So you see the utilization, you have a big chunk all the time if you have important project. But in our business workload, we have this curve, and lots of business come in together. They fight against the priorities. So that's a fun part we live in every day. High availability. We are 24/7 operations. I think everyone runs their clusters at 24/7. But do you have people who answer questions from your users 24/7? Not a whole lot. Do you really pay attention to the customer 24/7? Your beeper beeps at night, 2 a.m. in the morning, and you have to react to it? Some do, some don't. And in particular, for people who do global operations, I live in that world for quite some time, and it's not fun. I can tell you that. Funding. Funding is another big piece. So usually we build HPC systems, is a lot of money involved, multiple years of planning. We plan to use the system for X amount of years, right? Usually for national labs, they got a big chunk of money at the beginning of the game. So they can spend it here, spend it there, fix the systems. Life is good. But for us, funding, usually, we do the same kind of planning. We do multiple years of planning, but money not necessarily comes in. And there's no guarantee next year the funding will be the same as we planned it. So we cannot make procurement decisions until the money goes into our bank account. So that is another challenge in the design of the system. So, and it's highly integrated with the IT systems. Usually research systems, you have a site, you build your own kingdom, you manage your own network, storage, compute, authentication, security concern, everything, right? But enterprise, we cannot. We have to live with the enterprise IT. Cannot do that. Well, the last one is the worst. We have to support legacy codes that built 20 years ago that people didn't plan it well. They lost documentation, they don't know what to do. They just come in with a code, say, I need to run it, you better support it. That's always a challenge. System is busy all the time. This is the picture, not the one I took, Bangalore, India, where I sit through traffic. I can run to the locations faster than a car. So it's interesting, I see this picture, it almost like the cluster. We have big jobs, small jobs, 5-minute jobs, big jobs with like tons of memory requirements. We have all of that. So how do we blend in together? And the traffic jam it happens all the time. 24/7, we have job pans all the time. So with like over 95% utilization. What that leads into? Oops. So how we expand our system? We have lots of requirements comes in. Research HPC, usually they shoot for the best technology in the market. They want to build the biggest systems to impress people and to enable science research projects, which is the right thing to do, the good thing to do, and keep the industry going. At the same time, in industrial HPC, we have some other requirements. We want 24/7 operations, we want availability, we have like other set of requirements that we need to put into our design. And don't forget, enterprise IT has their own concern and requirement as well. Corporate IT security, how you protect your network from the outside challenge. Data protection, on top of HIPAA, on top of other government regulations, we have all different. GE confidential, public information, things like that, crown jewel information, things like that. It drives people nuts. And don't forget the business side of the game as well. Business leaders always come to us and tell us like what things we need to do. For example, you can only take down the system twice a year. It's like, and also unplanned outage is not allowed. And at the same time, they want all the utilization data inside out. They want to know the system better than us to some extent, so they can plan the work themselves without using the scheduler. So that's a challenge that we keep like fighting, because they want to make sure that they have the availability, they have the system that capable for them, is ready for them. So how we grow the systems is like lots of people pulling us. Let's switch the topic to technology, design, and architecture. So this one is the technology curve. Any of the technologies, it goes to early adoptions, and then lots of people like it, and then it dies down. It's a natural thing. Usually, research HPC, people, they like the latest, greatest. And usually, the technologies is built to tackle a specific problem. So when they first see it, oh my God, I like it, so I need it. Like we went through all the generations of like EDR, InfiniBand, like FDR. Our Intel partners like give us a new processors all the time. And HPC, industrial HPC, we're usually a little bit behind. Change is good, but you go first. Then you tell me like what you learned from it. Is it stable, good or bad? Before I will put it into my customer. But that trend is changing and we are sliding down. Industrial HPC is sliding down to join the research HPC people together to look into technologies. Don't forget, enterprise IT is still up on the top of the hill. They don't want to do anything. They don't want to do anything with this. One of the examples is I talked to enterprise people about InfiniBand. They don't even know what I'm talking about. So that's a challenge. New technology has another challenge too. That's why I put the defect tag there. Usually at the early stage, the road is very bumpy. You got all the problems, and thanks to the QA team, in the picture, there's only 3 guys are doing the QA work, and then after, voila, it's a GA. Then everybody goes in and check the code, check the products. That it brings us like the problem as well. Push and pull force. I got people tells me all the time, downtime is not acceptable. We need to support the codes like development like 20 years ago, and it needs to be stable. I got a user told me, don't put any new processors. I don't mind, it's a 5-year-old processor. I don't mind the old technologies as long as it works and stable, I'm happy with it. I had a user told me that exactly the same phrase. And at the same time, vendors tells us, hey, it's cool, it's great, it's a new technologies, come use it, and it works. Don't worry, if it doesn't, we'll fix it. And some other people challenge us, like, how come you're not using the latest, greatest? Thanks to those people who read the Insights magazine and learn what is a good idea in the world, and they try to dictate our roadmap as well. So thanks to that. And then, of course, finance people always ask us, are you using the greatest, latest, fastest systems in the world? Yet, no. Are you designing that? Well, wait a minute, there's other requirements that comes in. So to pull all the things, requirements together is a challenge. Cybersecurity. I cannot talk industrial HPC without bringing in the security because it's a big part that we focus on. In the old days, HPC systems live inside the kingdom. Why do we patch? I don't care, security patch is nothing related to me, we don't have outside threat. Enterprise IT will shield us from all of that. But the world has changed because we need to talk to all the global partners. Global users, we talk to machines, we talk to cloud, we talk to all the national labs for collaborations. So all that brings us with challenges, and for each of the specific players, we have to design the security model with different tactics to protect the different security threats. But at the end of the day, we want more collaborators. We need high bandwidth, low latency connections to all these partners, machines and things like that. HPC is pooling the enterprise IT. So HPC is we're all proud of, we use the latest, greatest, right? And then we look at enterprise IT, how come your network is so slow, your storage is not even parallel yet? And I have machines, I can have terabyte of RAM while they have terabyte of disk, right? So we are further ahead, but we are pulling them because we have to live inside an envelope and a cage together. So we are pulling them and they have to learn from us. And at the same time, don't forget, there's some technology debt. I know there is technology debt in every single company or enterprise. So we have to pull all that and help fix it. HPC and big data. Yesterday we talked about that. It needs to merge together. but to me, it's a marriage once for all. So those two have to stay together. Why? They are very good couples because they both are distributed storage processing platform in a stable and also a scalable environment. So they are actually the perfect match. But why HPC and big data? To me, it's like big data makes data available to HPC system faster, and it allows HPC to do simulations more effectively. And after the simulations, the production data is already there for you to validate your result. That gives like the engineers, the scientists, the advantage, so they don't have to go all the way to go back and pull data back and forth if everything is like right there in front of them. So with the marriage, it changes like the dilemma of HPC, where the HPC position is. In the old days, everything is inside the engineering bubble, and there's like ERP system is in the center of any of the enterprise. We pull information like from there, back and forth, but people pay attention to ERP systems the most, and it's the center of the universe. With Hadoop or big data platform, in the new data architecture, it's totally different. Right now, Hadoop or big data platform becomes the center of the universe, while the ERP, CRM pull data from the Hadoop, from the big data systems. At the same time, it feeds information to them. So what is the most important now? Really is the big data gets most of the traction and the attention there. So it generates problems too, this marriage. Availability. We talk about how to check systems and how to check things out. And to me, it is a case that inside GE, quality is the number one thing. We want to deliver the quality products, quality service to our customers. That's why GE have the big logos behind us, and it's the big philosophy behind us as well. Everything we strive to do it perfect. But if we look at any of the HPC problems or issues, it brings the system down to 2 nines. And it's just one single incident that will lock the availability down like crazy. Any one of you like ever try to restore 100 terabytes from tapes? Anyone? No? No one? Okay. I had that experience. It's about like 4 days of time. So it will bring the system down to like 2 nines. Leaders doesn't like these numbers at all. So what can we do to improve it? So that's a big challenge there. And I don't know, people can fix things like within like 3 seconds. If you see the problems within 3 seconds, you need to fix the problem. Then it will make you stay at 6 nines or something like that. Yeah. If you can do it, you need to come up the stage and teach us how you do that. 3 seconds, okay. We put a lot of redundancy. We see the availability problems. At the same time, we say, okay, we need to beef up the systems, right? Like compute node, we have a lot of them at 1 die, who cares, right? Network, we have like redundancy links, 1 die, we don't care, so show goes on. And storage, we have RAID controllers, like protection disk, like all things. But redundancy, does it really mean has 0 user impact after you do that? The answer is no. We find that a lot of redundancy that we put in the systems, on paper, it enhances availability. But if we look at deep down in the problem, users still see impacts. The jobs were lost. Yes, users can submit the job again, and go back and start again from the checkpoint, but that's time lost. And actually, we don't want that. So we need to do better than that. So help me out to solve this problem. We expand the systems like crazy because no way we can deliver enough resources to our customers. And with new technologies, all the things that I talk about, it leads to quite a bit of defects. Like usually in the early stage of like we deploy big systems, the road is pretty bumpy. So it means to productivity loss. So what are we doing here? We enlarge the systems, we lower the productivity. Is it the right equation? Probably not. So it's still a question to me, like what we're doing here sometimes. So our future, let me transition to what's going to happen. HPC team, of course, like people is the most important thing or element inside any of the solution, any of the enterprise. So to me, my team is the most important thing to me as well. So I look at it traditional way, building an HPC team, you find a couple geeks. Then you can form the team, sit together, some Linux experts, some people who do networking, and form the team, sit down and brainstorm a problem. That works in the old days, but modern HPC team cannot. We need to have like a lot more elements inside the team. People like software developers, solution architects, and also don't forget business analysts. I don't know how many of you inside your team has a business analyst like position, but I can tell you it's a very effective role and it's a very important role. Yeah. So if you don't have one like that, like try to bring one on, and you will see the difference there. So future requirements, like people need to know big data, people need to know programming, application support, data scientists, experience with large systems. And I put out the list, just like the jobsdb.com, monster.com says like we have all the requirements, but can we find people who is good at all of these things? The answer is like, it's very hard to do. When I talk to my colleagues like from other companies, from other enterprise, we all see the issues that we can hardly find good HPCers now, and we predict in future it will be even worse. So, focus area for industrial HPC. First one, high availability. We talk about systems like fail over, you can fail over, but our goal is like zero user impact. It's not zero problems to administrators, or we can delay the fix like, to the end of the week when we have time. It's not like that. We want truly zero impact to our users. Jobs will run no matter what happens to the system. That's one. 24/7 service. We need to find ways to make our life easier. So I don't want the people say happens at 2 a.m. in the morning, wake up my wife first before me. So I don't want that. So we need to have like monitoring, self-healing methods that we can do. Multiple system strategy. This one is probably one of the solutions, but we like to build one big system so we can show off what's our positions in top 500 lists, like how we compare to other people. Maybe multiple systems is the way out, that we build a couple of them and then let it sit here, there. It's not only for redundancy, it's also like a disaster recovery strategy as well. Automation, it will be a big thing for industrial HPC. For all the things we do now, if we were typing on a keyboard to fix a problem, we need to turn it into automation. We need to automate the whole thing. The 3-second rules is something new I try to introduce into my team, and I try to make the system fix a problem within 3 seconds. That's the end goal there. So we can retain our availability level. Of course, the last one is the software license cost. It's always a problem. Because we scale the system bigger and bigger, at the same time, we see the bill is it's more difficult for us to chew on. So we need a new way to work with software partners. I believe the fair share. That means that you do the work, you must have your own share. At the same time, we need to, it's swallowable. We can take it, internalize it, and then see the value there. So to some, not necessarily Altera, but to some other software partners that we have problem with the model today. So storage costs, we need to bring down platform costs. Everything, we have to press the price as low as possible. It will be a long journey too. So this one is my last page. I'm here to ask for help. One is the integrations to help us. Like, I don't think it will be able to be done by a person like me. Definitely not. No way it will happen. By my team, by GE, almost impossible. But we need the whole industry, the whole community to come to work together to bring big data, HPC together. The integration is the piece, because we need more brains to solve problems that we find in the future. And also, at the same time, we need a resources manager that can handle all the storage, big data, HPC, VDI, cloud, all blending together. So what's our end goal? We need to deliver capability, data, information, remote visualization, compute power, everything to our users whenever they need, and it must be in high quality. So that's the end of my presentation. Thank you for your attention.
Thank you.
So, any questions?
Questions? How are you?
Okay.
I'm going to ask, how are you finding your HPC people? I think everybody, well, how many people here, do you mind if I, how many people here also have problems finding HPC people?
Woo-hoo.
Okay, well, okay. I guess we should just move around to different companies from ourselves or something. I don't know. How are you finding? How are you solving that problem?
I think move around is not necessarily the good answer, but we need like a, first of all, HPC, it looks like cool, but compared to Facebook, Google, Yahoo, we are not that cool. So we need to make our industry like cool to the kids, right? That's one. And so that's the number one thing. And I think we need to go partner with universities, like to create more internships, like for them to open up more doors, like for them to start learning HPC, to see the value to advance science research.
Do you think one of the reasons to merge big data and HPC may be because big data is sexy and interesting to young folks, and we could get them into HPC by tricking them?
That's an interesting one. Big data, but people who focus on big data, usually they're computer scientists. They want to come in and work with the data scientists. They're not necessarily like system administrator level. They're not necessarily good programmers. So we need that type of people who's ready for the challenge, instead of like they come in and just want to work on the cool stuff and forgot the dirty hands stuff, like that they need to work on. So that would be the challenge for us.
Okay, thank you. Other questions? Sorry, I didn't mean to steal your guys' thunder. Okay, thank you again very much.
Thank you.